Hi, in this video, we're going to talk about Cisco ACL, the concept, particularly with the wildcard mask. The document we're going to discuss is located here. You can click to download it. It's a Word document. It's regarding the wildcard mask, which we'll call it WM in this video. The WM is a 32-bit in length to match the one-to-one with the IP address, similar to a subnet mask. The WM, it can be either 1 or 0 at any bit location, and this is not like the subnet mask requirement. You can put any 0, any 1 at any location of those 32-bit. It's okay, but it has to make sense, and we will discuss that. The importance of the WM bit is that if it's 0, if the WM bit is 0, there is a corresponding IP bit, and it can be either 0 or 1. If it's a 0 in the WM, then you can put either 0 or 1 over there. And this IP bit, we call it significant bit. If we put a 1 in the WM bit, then the corresponding IP bit in the ACL, you must put a 0 in there. If you put a 1 in there, your router or switch is going to change it back to 0. And while you're taking the Cisco test, you will be marked wrong. Okay, so it's important that if the WM bit is 1, we must put it a 0 in the IP corresponding bit. And the IP bit, we call it not significant. So the 0 is just like a placeholder, and we will discuss this more. To apply the ACL action, the access controller's action is usually permit or denied, and it's applied to a packet that's been examined. So in order to apply the action, all the IP bits in the packet that's been examined, it must match all of the corresponding IP significant bits in the ACL. So we'll talk about that in more detail. So this is a general principle, and we'll use the example to illustrate the concept. So I use the pseudo ACL with the shortened IP addresses to 8-bit for simplicity. 32-bit and 8-bit or even 4-bit doesn't make a difference. The principle is the same. So let's take a look at if we use the 8-bit. And this is not a true syntax, but a pseudo ACL. We call it access list 10. We permit with an action the IP address, let's say 00000001 with the WM, this. And now to explain what it means, we'll follow the steps. The first step is that we want to line up the ACL IP bits. For instance, this is the IP bits, and we write it here. And then we'll bring the WM bit to line up with it. Now we will check to see if it complies to the rule. We have mentioned on the previous page that if the WM bit is 0, we must put, is a 1, we must put a 0 in the IP corresponding bit. So we have 7 1 here. Of course, every bit here, we have to put a 0. That's just a rule, okay? There's a 7 zeros here. Okay. Now, the other rule is that if your WM bit is 0, if this is 0 here, your IP bit, according to what we have discussed, it can be either 1 or 0 in here. So we put a 1 here in this case as an example. Now we already verified the rule. All the WM bit, when it's 1, the corresponding IP bit are all zeros. So the first 7 bits are not significant. The 8th bit is WM bit is 0, so therefore we can put either 1 or 0 there, but we just happen to put 1 in here. So the 8th IP bit is significant. Now remember, we also mentioned that in order for the rule to apply, all the significant bit must match. So we're going to talk about the detail here. If a packet coming in with the IP address of 8 zeros here, then it will not be granted with the action by the ACL because the significant bit, it doesn't match. The significant bit here is the 1. And the incoming IP, the corresponding bit is a 0. So 0 and 1 doesn't match. Therefore, of course, this ACL doesn't apply to this particular packet with the IP of 8 zeros here. With the same reason, for any packet with IP of 7 of the X's here, where X is any combination of 0, 1, it could be 1, 1, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, whatever the number here, whatever combination, the 7 of those bit position here, we call it not significant, meaning that, hey, it's a placeholder here. I don't care what's in those 7 bits. This access controllers, this ACL, is possibly will be applied to you because those bits are not significant. We are not going to compare. We're only going to compare the significant bit. So therefore, as long as your number 8th bit doesn't match, which is the significant bit doesn't match, and all the non-significant bit, it doesn't matter. So therefore, you have a lot of them. It will not be applied. It will not be granted with the permit. Now, the third one tells you that if you come in with the packet, its IP is 7 zeros in the front, with 1 here, it's like a perfect match. But it doesn't have to be, because I already tell you here in the next line. Whatever the X in the front, it could be any number. So it doesn't have to be 7 zeros here. This 7 zero is not significant. We don't care. It could be any combination. As long as the significant bit here match the one in the rule, then this ACL will be applied to you. And of course, we say permit. Therefore, you will be permitted. Right? So the conclusion here is any packet with the 8th bit of 1, it will be applied with this ACL line, action. And any packets with the 8th bit of 0, and we don't care about the rest of the bit, it will be ignored by this line. Right? And then this is not the end. When this packet coming in, it's been examined against the ACL rule line number 1. If it doesn't match, then you will go to try to match it on a second line. And we will discuss that later. Now we are going to further shorten the IP address to only 4 bits to further clarify the concept with more examples here. Okay, so we shortened the access list to something like access list 10 still, permit still, okay. IP now is 1010. And the WM is, let's say, 0000. Okay, this is actually the equivalence of that. And we will talk about that. So let's focus on this one first. Okay, the front part first, the one that's not highlighted. Now, again, we are going to line up with the IP 1010 with the WM, which is 4 zeros here. Well, according to the rules, as long as your WM is 0, you can put whatever you want on your IP address, as long as it makes sense. We can consider it as if it's a game or an event that you will go in. You'll be given with a card, invitation cards. And the invitation cards has 4 numbers. Some of those invitation cards you can get into the event, some of them you cannot. Now, if the gatekeepers that host a car with the rules say access list, permit 1010, and then WM 0000, then only the person who has the invitation card that is listed as 1010, it will be permitted. Because we say, hey, in order for this action, and it happened to be the permit action, in order for this ACL, for this car to apply to you, you must match all the significant bits. So no matter the car, no matter what number you have, it could be 1010, it could be 1110, it could be a total of 16 combinations, but we don't care about that. The only one that will be applied is the one who has the 10 and 10. Okay. So all the rest of us holding the car with any number other than 1010, this rule doesn't apply to me, to us. We just have to wait and see if there is a second rule to allow us to get in. But according to this first rule, there's only one person that holds the car with 1010 can go in. And that one person is similar to say it's the same as the keyword host. Therefore, we can say XFS 10 permit host with the IP of 1010. So while WMASK, the WM of the all zeros here is same as the keyword host. Now we are going to change it a little bit. We change the WM from the 4 zeros to 0001. And we maintain the same IP in the rule. According to the rule, if it's 0000 in the WM, then I can put anything. So 101 is okay. That's significant. That means everyone, if you want to apply to this rule, you must have 101 in your car. And the corresponding bit of 0 towards the 1 in the WM, it must be a 0 as a placeholder because we don't care. This is insignificant. Therefore, we don't care about your force bit. It can be 0, it could be 1. As long as you match all the significant bit, which in this case is 101. Okay, so if we change this rule, the gatekeeper now receive a new card from the boss and say, hey, for whoever got the invitation that holds 1010, 1011, they can go in. And this is the rule that the gatekeeper, the ACL, received. Because according to the rule, we must match all the significant bits in order for you to be applied with the action. And the insignificant bit doesn't matter. So we have 2 packets that will receive this permit action. Now, not all the action is permit. So we are going to start to use deny. And I'm going to skip writing the whole line in here. We're just going to say deny with an IP with the WM. And if we put that, then again, okay, this is like a host, right? That means everything is 0 here. That means you can put anything you want. However, all of them are significant. Therefore, you're denying a host of this one. So if we use the same example for the event that's invited with all of us here, and you show them the car, only one person with the car holding 1010 will be denied. All the rest, no matter what your car number is, will be permitted. Right? Of course, when I say permitted, that's really not the right statement. This ACL only says we deny that person. It doesn't actually give you the rights. It doesn't actually grant you the permit right. So that is what I just say is a very common misunderstanding or interpretation of the ACL. In order to be denied or permitted, you must match a specific line. So when we were lucky, we didn't hold a car of 1010. We didn't get denied, but doesn't mean that we can go in. We have to match the second line, see if we got lucky. All right. Now let's keep going. We will talk about that in detail later. Now we keep going on with this sample, 1010, and then we change the WM to 0001. Then of course we're going to deny what? Deny whatever the significant here. Significant is 101. So we're going to deny 101, deny 101, and the last bit here is insignificant. So as long as your first three bit is 101, and we don't care about your fourth bit, you'll be denied. Therefore, we will deny both the 101, the 0, and the 101, the 1. Now, if we use all ones in here in the WM, we got to put all zeros in here. That means nothing needs to be matched. It's green light for everyone. It's like permit any. We don't have to match anything. There is no significant bit. Okay, now let's talk about the additional notes here. All examples discussed, we only have one line in this ACL. When the packet matches all the significant bit of the line, the action is then applied to the packet. Then it's all done. When the packet doesn't match all significant bit of the line, the packet will continue to be examined by the second line in the ACL. If there are more than one line, there are more lines in there. In addition to that, there is an implied deny IP any. So if you get examined by the second line, third line, and nothing applies to you, then you will hit the end, the implied deny any at the end of the ACL. That means if you have nothing matched in all the line, you'll be denied. When a packet doesn't receive any action from the lines of the ACL, it will be denied by the imply. That's what we just mentioned. If we explicitly add the deny IP any, that means we put a line, we say that deny IP any at the end of the ACL, we'll be able to see the number of packets that get denied and hit the particular line. Every line in the ACL, when it deny or permit a packet, it will have a hit count. And this is the great information for troubleshooting. And we will apply this technique during our lab exercise. Now we're going to step a little bit forward to look at the discussion board 8-1. That is using the real, the question number 1, using the real example. So we're going to explain using what we have learned for this particular ACL with 3 lines here and with additional syntax. And first line, it says AC access list. And before we go into detail, if it's a little bit complicated or a little bit confusing for this part of the discussion, that's perfectly okay. We are going to have another document review even more details of what we just went through. And then we'll do 4 of the hands-on exercises, and then we will come back to the discussion board. So this is just give you a heads up, okay, on what's coming. So ACL, anything more than 100 is extended ACL. It gives you more detail instead of just permit with 1 source address and 1 WMASK. That's it. It will give you a source, and they give you a destination of any. We just use any. Any means any. So we are going to deny TCP protocol for an IP address with the WM of 00063. And no matter where they want to go. So this is the source with the WM, and the destination with any IP, any destination IP with any WM, EQ, SMTP. So as long as your IP address fits in here, no matter where you want to go, as long as you use SMTP ports on the TCP, we will deny you. That's what this line is saying. Second line is more straightforward. You say deny TCP from any source to any destination, as long as it equals port 23, which is a telnet. And then the third line, we say, hey, we have to deny. So the rest, we permit IPNN. So as long as you don't go out SMTP from that section of the IP, and you do not go out to telnet, you're okay. You will be hit the third line to get a permit. Therefore, it's important to know also in an ACL, you can have deny anything you want, but you must have at least one permit line. Otherwise, you see all your ACL is all deny, and then with the implied deny at the end, deny IPNN at the end, we may as well just go ahead and unplug the cable from the interface. That's it, done. I mean, that ACL will deny everything, right? All right, so now we also talk about, once we understand the ACL, how do we apply it? We apply it, say, hey, go to interface Ethernet 0, or fast Ethernet 0, or interface GI 0/0/0, whatever we have been doing, just go to the particular interface. And you tell them IP access group with the access list, 110, and inbound or outbound. When we say inbound or outbound, means that we sit inside the router or Cisco device or switch. We sit in the Cisco device, and the packet is leaving out of the interface. Okay. So whatever the packet that's from the Cisco itself inside, going out from the Ethernet 0 are subject to this ACL. So that's the explanation of this ACL. And how do we be more specific about the IP addresses on the first one? Now, use the one that we just learned. IP address 10.1.1, right? And 128, we say that. And 128 is the 1, 0, and the 7 zeros. That's 128. That's fine. And then we line up with the 00063. It's very similar to what we did with WMASK. So the 00063 is like this, WM, and we put it in here. So what we need to look is that, hey, what is the 0 inside my my WM here? The significant bit. Look, it's half of, oh, got it. Anyways, you can see that from this cursor here, on the left, all of those 24-bit, 25, 26-bit are significant. So in order for this line to apply to you, all this significant bit must match. So therefore, when the packet coming in, it must carry on with the first 26-bit of 10, 1, 1, and the 25th and 26th is a 1, 0. Therefore, it is from 10, 0, 1, 0, with 6 zeros smallest, which is 128 decimal, smallest IP, to the 1, 0, because we must match the significant bit, right? And all the rest, the biggest one is 191. It's the largest IP address. So therefore, it's from 128 to 191. And if we want to summarize it, you can take a look at it. Oh, it's like, oh, we have to match the front. So therefore, this front is similar to a /26. If we wanted to do it, to summarize it, it's like 10.1.1.128 in here. And of course, you just gave me this WM. But I want to figure out what IP addresses will hit this line, will be applied with this line, will match all the significant bit. Is that it's a /26, because if I put some mask in here, all of them coming in will be 10.1.1, but with the first 2 bits of the last byte of 1, 0, right? So this is the answer. We will not allow SMTP port 25 email to go out if you send it from 10.1.1.128 with the subname as 255.255.255.192, or you can say /26, or you can say IP range from the 128 to 192 to any destination. We will not allow it to be sent. Well, this is really not very specific enough. This is specific enough in the IP sense to be sent out from Ethernet 0. I have to add it in here, okay? And so the ACL, you can put it in there, but it will not take effect unless you apply to an interface and give it a direction. So this statement here is completely true, but we have to add it to say, hey, no SMTP, so on and so forth, to send out from this IP range, to send out through Ethernet port 0. Okay. If you send it from port 1, port 2, then it doesn't matter. Okay. And the second line, of course, is the same thing. The second line, it's shorter, so I put more specific information there. No telnet traffic from any source to any destination will be allowed to leave the Ethernet 0, okay, from that device. So the first line, if you want to be more complete, then you should say, hey, no SMTP information here with this subnet mask to any destination to leave the Ethernet 0 from the Cisco device. And all other traffic will be allowed to leave Ethernet 0 device. Okay, so that's the end of this document. I will make another recording to talk about more detail of this ACL concept and WM with 4 or 5 of those exercises to clarify it.